So algebra, we're at the chapter 5. There's a lot of stuff in chapter 5 that's the same. We're still doing opposites. We're still going to do the same to both sides. Some of those things are never going away. But there's one big difference is we're shifting gears from a thing called equations to a thing called inequalities. So I think we've talked about this year, other days. Anybody have an insight into what makes an equation different than an inequality? Any memories on such a thing?
It's you're equal to
Who's equal to?
the x and the number.
The equations or inequalities have equal to?
The inequalities. The equations.
Equations. Equations are always going to have an equal sign. That's what we've been used to up from most of the year till now, is most of the time equal signs. Inequalities don't have equal signs. Inequalities have maybe some other stuff.
Greater than, less than.
We could have a greater than, we could have a less than.
Or the greater than, less than with a line under it.
Yeah, so if I do this, what's that mean?
It's either less than or equal to.
Close.
Greater than.
It's either greater than or equal to another number. So if I asked you, is 3 greater than or equal to 2? That answer is yes. It's either yes or no. That answer is yes because it's greater than. If I said this, the answer is yes or no?
No. Yes.
Yeah.
Yes, because it's equal to. If I do this, you'd say
No.
no, because it's not greater than or equal to. We just need one or the other to do that. So this symbol is called
Less than.
or equal to. It would be true if we're,
Less than.
it's also true if we're equal to. The only way it's not true is if we're,
Not greater than.
which is greater. So if I gave you something like this, true or false?
True.
True? No.
False.
5's not less than 4, and 5's not equal to 4. That's just a failure. 4 compared to 5?
True.
True, because it's
Greater than.
less. That's true because they're equal. So we're either less or equal. And there's one more symbol that's in the inequality family.
Equal to. Or not equal to.
Not equal to. So that would be true anytime the numbers that I give you are,
Not equal to.
yeah, in other words, they're
Different.
different. If they're different numbers, we could use the not equal to sign. Question about the idea of the inequalities and the signs and stuff we'll see. Okay, what they're going to ask you to do is graph these, not graph them on graph paper. It would be a good idea to own some graph paper in your possession for someday, but maybe not till spring. I don't think we'll need graph paper till around there, but you will need it eventually. But they're going to ask you to graph pieces of the number line. So people watching the video on camera, sorry you can't see the number line, it's not really worth panning up. But we're trying to graph like a chunk of the number line. So if we were going to do this in a long way, to show you x equals 2, and this is more than what I'll ask you to do in the homework, we could construct ourselves like a little number line here. Reproduced number line down a little lower on the board than where it lives. If I wanted to graph x equals 2, do you know how you could go about doing that?
Put a circle, like where the line is.
Yeah, go right on top of
2.
the 2. Go right on top of the 2 and just like put a dot there. And that would be a way that we could do that. If I want to go x greater than 2, a longer way to draw this than what I'll ask you to do would be to reproduce a number line. What part of the number line would I want to get on here if x is greater than 2? Some positive stuff, yeah. Not all positive stuff, but some of the positive stuff, yeah. There's a full number line. If I just want to use that number line to show which part is x greater than 2, where would I live? Say again?
At the end of the 2, it means the 3 4 dies.
Yeah, we'd want to be working this like 3, 4, 5 zone. We'd want all of that, and you'd want to go how far? Forever. So we'd be in this 3, 4, 5 zone forever. We would want 2 exactly, or we would not want exactly 2.
Not exactly.
Not exactly 2, but we'd want to get really, really,
Like 2.1.
yeah, like 2.1, like really, really close to 2. We'd want to get to the right of 2 and go really, really, really close to 2. There's a way we can use math symbols to draw and show we don't want the 2. Like here we did want the 2, so we put a dot there. If we don't want the 2, there's a way we can show that. And if people who had this before might remember this. People who never had it before have no idea what I'm talking about probably. Does anybody remember who had this before? A way that here I showed I want the 2, here I could show I don't want the 2.
You draw an open circle.
Yeah, do it, not a solid filled in dot, but do like an open circle. Open circle is a way to communicate. I don't want 2, but I do want everything to the right of it. That would be a way that we could graph this. 2 is out, everything to the right of it is in. This would be a way to show that we want the 2.1s and the 2.01s and the 2.000000000s. Everything bigger than 2 is what we want. That would be a way that we could graph that. What I'm going to do is shrink the graphs down. I think the way the book has in mind is to do something more like that, to draw a number line and then try to highlight the part that we want to keep. I find it sort of distracting, and if you could imagine some of you being a little bit on the messy side, sometimes it's hard for me to tell what you did want and what you didn't want, because here, did we want this stuff? No. Since I went like super heavy scribble, it's pretty clear I want this and I don't want that. But sometimes we get Algebra 1 people that everything you draw kind of looks like a scribble. And so it's a little hard for me to go with which scribble do we want and which scribble we don't. You feel my pain, don't you? Yeah, I can tell. You're like making eye contact with people about their scribbles. So here's how I'll solve that problem is not at all even draw the part that I want, that I don't want, excuse me. So if I'm going to redraw this, 2 is my key number. I don't want the 2. So what did I do about not wanting the 2?
Open circle.
Open circle. And then we went to the right. I'm going to be happy with that graph. I don't care if you show me the 3, 4, 5, because I think we can have confidence in each other that both you and I know how to count. And after 2, we kind of know 3, 4, 5 is coming. So I don't feel that I need the 3, 4, 5 for a sense of scale. So if I wanted to go do this, 2 is my key number. Do some sort of marking there. Fill in or no if I'm doing a less than.
No.
No, because 2 itself is not less than 2. So I'm going to leave this just open. And if I want to show I want all the numbers that are under 2, I'd go everywhere to the left. So for this, 2 is still my number. I got a little boring. I just use 2 every time. So we're going to do a bunch of pictures with 2s. 2 is always going to get some sort of like a marking on it, whether we maybe fill it in or maybe we don't. If I'm greater or equal to 2, does 2 itself work? Does 2 itself make that a true story? Yes, because 2 is equal to 2. So to show I want the 2, I'm going to color that in. If I also want the stuff that's greater, I'm going to head to the right. So for this, less or equal means fill it in because I want it, and the less part sends me left. If it's not equal to 2, I want everything that is not equal to 2. Do I want to fill in? No, because I don't want it. But where can I find everybody who's not equal to 2?
Both sides.
Both sides, both to the right and to the left. That's the way I'm going to say graph these. Don't try to graph like the full number line. If I ask you to graph this, I'd actually be okay if you just went like this. And just called it a day. That's the only little speck of the number line I want out of this one is 2. That's it. Question about those basic 6? Okay, we probably need to swivel me a little bit now. Either you care to do that, just capture it till the end of the line. Good?
Can I go with
Yeah. Question about the beginning part? Okay, so here's what the homework will look like. The first part of the homework is going to say, I want you to graph a solution to this equation. So equations come in, you have to solve the equation, so use all the skills we've had all year. What would you do to solve this? Subtract the 5, add and subtract first, gets us down to
2 or
12. Then
Divide the 3.
divide the 3, get
You get x equals
4. Question about the solve. So then throw that 4 into a picture, have some sort of a dot going with the 4, fill it in or don't fill it in, fill it in. And then are we going any which way?
No.
No. If I only want the piece where x is equal to 4 and that's it, just do that little mini picture, call it a day, get out of it. They're not going to do this to you yet, but where the chapter's going to head, preview of coming attractions, if this is a grader, you would probably expect that this is going to be
A greater.
still a grader, and this, when you get done,
A greater.
is still a grader. Sometimes the sign will turn, that's common, we'll talk about that another day. This one it wouldn't, that would be all fine. If we start with a grader, we roll the graders. If we had to graph that, fill in or no, fill,
Don't fill in.
don't fill in, and the grader would go
To the right.
to the right. What would make me do a fill-in?
If it was equal to.
If I threw that equal to choice when I created the problem as the author of the problem, if I threw the equal on there, now we're doing the fill-in. Question there? So first part of the homework will do that. First part of the homework, they'll give you an equation. They're guaranteed all going to have equals. They're guaranteed all just going to be a graph with like a dot that's filled in when you graph them. Then the middle part of the homework is going to go something like this. They're going to give you equals, greater, lesses, the whole bit. So what you'll want to do is just make pictures. 4, 5, 6, 7, 8, 9. Dot of some sort. Maybe we fill, maybe we don't. For this one, fill or no?
Fill.
Fill. You're going to fill it anytime it has an
Equal.
equal. So, fill or no fill? No.
No fill. No fill.
No.
Fill.
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 Fill. Because these have equals.
No fill.
No fill because the equals is a no. Question about the fill versus not. And then go by the symbol. When it's equals, we're going to go
Nowhere.
nowhere. If it's less,
Okay, go left.
go left. When it's greater,
Go right.
go right. This then goes
Left.
left. This goes
Right.
right. And this goes
Nowhere.
Both.
everywhere.
Oh,
If it's not equal to, we want the bigger and smaller numbers both. Question about that, Ron? Why is this column going to be a little more awkward? Some of them.
They're swapped.
They're swapped. They're like backward. So here's the rule. We're doing everything from the x's point of view. So here, from x's point of view, x was more than this number. Because like Pac-Man or the alligator or however this was taught to you as a little person, the mouth is eating the bigger thing. X was bigger than 6. So from x's point of view, we're bigger, so we go right. But when I go popping over here and they're backwards, that's going to like mess up some of these from what you'd expect. But go dot, 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 dot. We'll decide on the fill in a second. Do our number sequence, 1, 2, 3, 4, 5, 6. Fill or no?
No.
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 Yes.
Yes, because of the equals.
Yes.
Yes, because of the equals.
No.
No.
Yes.
Yes, because of the equals. In this whole column, you saw less, you went left. Is that still true, or is that messed up?
Messed up.
It's messed up. Because when we go backwards, we have to think about, from X's point of view, is X the bigger thing or is X the smaller thing?
Bigger.
X is bigger because the alligators are eating the X. So from X's world, X is the big thing, so we have to go
Right.
right. Previously, we saw graders, we always went right.
That's
Is-
the less than.
Now we're going opposite because X is the bigger or littler number. Littler. The alligator's eating the 2, X is little. So little goes to the left. This one,
We go to the right.
go to the right because X is the bigger number. This would go
Left.
left because X is the littler number.
Both.
This one,
Still both.
still both. This one,
Nowhere.
still no. Question about that world, they'll give you some stuff, forward, backward, whatever, left, right, whatever. If they decided to throw you a negative, would that be a big deal? What would you do?
Just do it now.
Just make the number be a negative. What if this were some crazy decimal?
Just put it the same.
Just make this a crazy decimal. What if this is some crazy fraction?
Just make
Just
it
keep
crazy
it-
fast.
Just make that same crazy fraction. It doesn't matter where the number is. Something about that world. The last world, pretty much you've learned, I think, over the year, everything we can do forward,
We can do
we can do
backward.
backward. So they're gonna take you backward at the end, and they'll give you the picture. So we're gonna go X, 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 1, 2, 3, 4, 5, 6, and then it's just a matter of picking the magic sign. So this, we went open and headed right. So which symbol has been doing that?
Right.
Greater than. Open went left, less than. Filled in went right,
Greater than with the line on the
greater or equal to. Filled in went left, less than equal to. Went nowhere,
Equal to.
equals. Went everywhere,
Doesn't equal.
not equal. And that's the last game you'll play. 30 minutes, this is doable. In 30 minutes, if you want to punch this out. We're working page 188. It goes 1 to 24. The first 6, they'll have you solve an equation and make a graph, and the graphs are just going to be one of those like lonely little dots that went nowhere because they all have equal to's on them. 7 to 18, they're going to do a variety of these. They didn't write any of them backward like I did, so good for them. They made it nice on you today. Everything is like these where the variable's on the left, no tricks up their sleeve. They did some decimals, fractions, weird numbers, but like we said, the number really doesn't matter. That'll take you to 18. Then the last 6 from 19 to 24 are like these. They draw the pictures and they want you to create the problem. The weird one is 21, and we'll just talk about 21 tomorrow. 21's weird, so if you get to 21 and you're like, that's weird, yeah. 21's weird, that's probably just worth a conversation tomorrow instead of right at this second, other than to warn you. 21's weird, and if you don't get it, don't worry about it, we'll talk about it tomorrow. Any question before we call that a wrap? Push the stop button.
Yeah.
Thank you.